Quantum physics just collapsed. This discovery changed everything. Something happened inside a laboratory that should have been impossible, not difficult, not strange, impossible. A group of physicists believed they were observing one of the smallest and most insignificant particles in the universe, a tiny fragment of matter drifting through space according to laws humanity thought it already understood. But the moment they looked closer, reality itself began to behave differently. The particle changed, not metaphorically, literally. It acted one way when nobody was watching, and another way the instant it was observed. At first, scientists assumed there had been a mistake, faulty equipment, corrupted data, human error, because the alternative was terrifying. The alternative suggested that the universe was doing something no machine, no equation, and no theory should ever allow. It was responding to observation. For centuries, humanity believed reality existed independently of us. The stars burned whether we looked at them or not. Galaxies collided in the darkness without needing witnesses. Space itself seemed cold, mechanical, predictable. Isaac Newton transformed the cosmos into a giant clock. Albert Einstein refined that clock into a masterpiece of cosmic precision. Everything appeared governed by elegant mathematical laws. Then quantum physics arrived and shattered the illusion. Suddenly, particles existed in multiple states at once. Matter behaved like waves. Objects separated by unimaginable distances appeared mysteriously connected. Time itself stopped behaving normally. And buried inside the data was a possibility so disturbing that many scientists refused to accept it. What if reality is not truly real until it is observed? That question ignited one of the greatest scientific crises in human history. Because this was never supposed to happen. The deeper physicists explored the quantum world, the more the universe stopped resembling a machine and started resembling something alive with uncertainty. A place where certainty dissolves, where cause and effect begin to fracture, and where observation itself appears to shape existence. Some scientists called it absurd, others called it revolutionary. A few quietly admitted something even more unsettling. They no longer understood the universe they had spent their lives studying. And now, after decades of experiments, new discoveries are forcing physics toward a terrifying possibility. The foundations of reality may be fundamentally incomplete, not because science failed, but because reality is stranger than the human mind was ever prepared to imagine. Tonight, we are going to step into that fracture, into the moment physics began collapsing under the weight of its own discoveries, into a mystery so profound that even the greatest minds in history struggled to accept it. Because what scientists uncovered inside the quantum world did not simply challenge modern physics, it challenged existence itself. The lie we believed about reality. For most of human history, the universe felt stable. When ancient civilizations looked into the night sky, they saw order. The stars moved in patterns. Seasons returned with precision. The moon obeyed its cycle with almost supernatural consistency. Reality appeared reliable, structured, understandable. Even before science existed, humanity instinctively believed the cosmos followed rules. Then came Isaac Newton. With a few equations, Newton transformed reality into something mechanical, predictable, elegant. The motion of planets, falling objects, even the tides of the ocean suddenly obeyed invisible mathematical laws. The universe became a giant machine operating with perfect precision across space and time. For the first time in history, humanity believed it had decoded creation itself, and the confidence only grew stronger. Centuries later, Albert Einstein expanded this vision into something even more extraordinary. Space and time became woven together into a cosmic fabric. Gravity was no longer just a force. It became the curvature of space-time itself. The universe looked majestic, rational, almost poetic in its order. Einstein's equations predicted black holes before anyone had seen them. They predicted gravitational waves long before humanity had the technology to detect them. Every new discovery strengthened the same belief. Reality makes sense. The cosmos may be vast, but it is understandable. That idea became the foundation of modern civilization. Every computer, every spacecraft, every technological miracle emerged from the assumption that the universe behaves according to fixed rules waiting to be discovered. Science became humanity's most powerful language because reality appeared stable enough to translate into mathematics. But hidden beneath this confidence was a problem no one initially noticed. The closer scientists looked at reality, the stranger reality became. It started with atoms. At first, atoms seemed simple, tiny building blocks forming the physical world. But when physicists began exploring the subatomic realm in the early 20th century, the universe suddenly stopped behaving logically. Electrons refused to stay in fixed positions. Particles appeared to move through solid barriers. Matter behaved like energy. Energy behaved like matter. And worse than all of this, the act of observing these particles appeared to change their behavior. Not symbolically, physically. It was as if nature itself became unstable under scrutiny. The deeper scientists descended into the microscopic world, the more the universe resisted being understood through ordinary human intuition. Cause and effect began to blur. Certainty dissolved into probabilities. Events no longer unfolded with mechanical precision. Instead, reality became governed by uncertainty, randomness, and invisible possibilities. The old universe began breaking apart. Newton's machine could not explain it. Einstein's structured cosmos could not fully contain it. For the first time in centuries, science encountered something terrifying, a layer of reality that refused to behave rationally. Many physicists reacted with disbelief. Some openly rejected the implications. Einstein himself spent years fighting against the conclusions emerging from quantum mechanics. He could not accept that nature, at its deepest level, might be governed by probabilities instead of certainty. To him, the idea felt incomplete, almost chaotic. That was when he spoke one of the most famous lines in scientific history. God does not play dice with the universe, but the universe remained silent, because experiment after experiment continued producing the same impossible results. Particles existed in multiple places at once. Information seemed to travel instantly across space. Reality behaved differently when measured. The universe no longer looked like a machine. It looked like a mystery observing itself. And buried inside this growing chaos was a terrifying possibility humanity had never seriously considered before. What if certainty itself was only an illusion created by the limits of human perception? What if reality had never been stable at all? That question would soon lead scientists into an experiment so disturbing that even today, decades later, physicists still argue about what it truly means. An experiment that did not merely challenge our understanding of the universe, it challenged whether observation itself creates reality. The experiment that terrified scientists. The experiment looked harmless. No giant machines, no exploding stars, no massive particle accelerators stretching across continents. Just a beam of particles, a barrier with two narrow openings, and a screen waiting behind it. Simple, almost laughably simple. And yet, this experiment would become one of the most disturbing discoveries in the history of science. Because inside that quiet laboratory, reality began behaving like something out of a nightmare. Physicists started with a straightforward expectation. If particles are solid objects, they should behave like tiny bullets. Fire them toward a wall with two slits, and each particle should pass through one slit or the other, leaving two clear impact patterns on the screen behind. That is what common sense predicts. That is what classical physics predicts. That is what reality itself should predict. But the universe had other plans. When scientists fired light particles toward the slits, something impossible happened. Instead of producing two simple bands behind the openings, the particles created an interference pattern, a strange series of waves spreading across the screen like ripples colliding in water. The particles were behaving like waves. At first, physicists were shocked, but they found a way to rationalize it. Light had already shown wave-like behavior before. Perhaps this was merely another property of energy. Then the experiment became terrifying. Scientists decided to fire the particles one at a time, not millions, not thousands, one single particle. Surely now the interference pattern would disappear. A lone particle should travel through one slit or the other like any ordinary object. But it did not. Even when sent individually, each particle somehow interfered with itself, as if one particle traveled through both slits simultaneously, as if reality itself had split into multiple possibilities before collapsing back into one outcome. Physicists could barely believe what they were seeing. How could a single particle exist in multiple states at once? How could matter behave like probability instead of physical substance? And then came the moment that changed everything. Scientists attempted to observe which slit the particle actually passed through. That was all. They simply tried to look. And the instant measurement devices were installed, the interference pattern vanished completely. The particles stopped behaving like waves. They started behaving like ordinary objects. It was as if the universe noticed it was being watched. Nobody expected this. Nothing in classical physics prepared scientists for a reality where observation itself alters physical outcomes. The equations worked. The predictions matched the data. But emotionally, intellectually, philosophically, the implications felt almost impossible to accept, because this experiment suggested something horrifying. Before observation, the particle did not possess a definite reality. It existed as a cloud of possibilities. Only when measured did it choose a state. Think about how deeply disturbing that idea truly is. For centuries, humanity assumed the moon existed exactly where it appeared, whether anyone looked at it or not. Mountains stood solid, oceans crashed against shores, stars burned in silence across billions of light years independent of human awareness. But now, quantum mechanics was whispering something radically different. At the deepest layer of existence, certainty may not exist until interaction occurs. Reality itself may emerge from observation. Some physicists tried to avoid the philosophical implications entirely. They insisted quantum mechanics was merely a mathematical tool, a way to calculate outcomes without asking dangerous questions about meaning. Others could not ignore the growing unease, because the experiment kept working. Repeated endlessly across decades, refined with increasingly advanced technology, the results never disappeared. Again and again, reality behaved differently, depending on whether information about the particle's path existed. Not human eyesight specifically, information itself, knowledge itself, and suddenly the universe no longer felt passive, it felt responsive. The deeper scientists examined the experiment, the more unsettling it became. Some interpretations suggested particles do not decide their state until measurement occurs. Others proposed parallel realities branching endlessly across existence. A few theories implied that observation and consciousness might play roles science still does not understand. The implications spread like fractures through modern physics. Because if particles can exist in multiple possibilities before observation, then what exactly is reality when nobody is looking? That question haunted the greatest minds on Earth, and it would soon lead science toward discoveries even stranger than the experiment itself. Because the next revelation would suggest that space, distance, and separation may not truly exist the way humanity believes. When physics started breaking, at first, scientists hoped the madness was isolated. Maybe the strange behavior of quantum particles only existed inside microscopic systems too small to affect the real world. Maybe the bizarre outcomes of the double-slit experiment were temporary gaps in human understanding. Strange, yes. Uncomfortable, certainly, but manageable. Then the universe became even stranger. Physicists discovered something that shattered one of the oldest assumptions in human history: the belief that objects separated by distance are truly separate. The discovery began with two particles born together inside the same quantum event. According to classical logic, once those particles moved apart, they should become independent objects. One particle here, another particle there, separate entities existing in separate locations across space. That is how reality appears to work. But quantum mechanics revealed something terrifying. The particles remained connected, not metaphorically, physically, instantly, no matter how far apart they traveled. This phenomenon became known as quantum entanglement, and when Einstein first encountered the idea, he hated it. To him, it violated the very structure of reality. Nothing should communicate faster than light. Nothing should influence another object instantly across vast distances. Yet the equations insisted it was happening, and worse still, experiments kept proving the equations correct. Imagine two particles drifting billions of miles apart across the universe. One near Earth, another near the edge of a distant galaxy. According to quantum physics, changing the state of one particle instantly affects the other, as though distance itself has no meaning. No signal traveling through space, no delay, no visible connection. Just immediate coordination between objects separated by impossible distances. Einstein called it spooky action at a distance. Not because he believed in mysticism, because he understood how deeply disturbing the implications were. If entanglement is real, then the universe is not built from isolated objects. Beneath reality's surface, everything may remain connected through invisible structures existing beyond ordinary space and time. The implications were catastrophic for classical physics. For centuries, science rested on locality, the principle that objects are only influenced by their immediate surroundings. Cause creates effect through physical interaction across measurable distances. Quantum entanglement demolished that assumption. And the deeper scientists investigated, the more reality itself began collapsing under pressure. In 1964, physicist John Bell proposed a revolutionary theorem capable of testing whether hidden variables secretly controlled quantum systems behind the scenes. Many scientists hoped Bell's work would restore order to physics. Perhaps particles already possessed predetermined properties before measurement. Perhaps quantum uncertainty was merely an illusion caused by incomplete information. It was humanity's last attempt to save determinism. Then the experiments arrived. Again and again, Bell's inequality was violated. Again and again, the universe sided with quantum mechanics. The particles were not secretly carrying hidden instructions. Reality itself appeared fundamentally non-local. This was not merely a scientific update. It was an existential rupture. Because if entanglement is real, then separation itself may be an illusion. The distance between stars, the distance between galaxies, even the distance between you and the cosmos. All of it may emerge from deeper structures humanity still cannot perceive. For the first time, physicists were forced to confront a possibility once reserved for philosophy and metaphysics. Space may not be fundamental. The universe may be woven together beneath visible reality through hidden informational connections, transcending ordinary physical laws. And suddenly, quantum physics stopped sounding like science. It began sounding like a message from the edge of comprehension. Some scientists resisted emotionally. Others became obsessed. Entire careers were spent trying to escape the implications or reinterpret the mathematics into something more comforting. But nature refused to cooperate. Every new experiment pushed physics further away from certainty. Entanglement was demonstrated over increasing distances. Quantum states were transferred between particles separated across cities. Laboratories confirmed correlations so precise and immediate that even today, no classical explanation fully accounts for them. The universe behaved as though space itself was secondary, as though reality operated from somewhere deeper than physical matter. And hidden within this growing crisis was an even more disturbing realization. If particles can remain connected beyond distance, if observation influences physical outcomes, if certainty dissolves into probabilities, then perhaps matter itself is not the true foundation of existence. Perhaps reality is built from something far stranger, something humanity is only beginning to glimpse. That possibility would lead physicists toward a discovery so profound that some scientists quietly admitted it may redefine the meaning of existence itself. The discovery that changed everything. For decades, physicists believed they were searching for smaller pieces of matter, smaller particles, smaller forces, smaller building blocks hidden beneath reality. But the deeper science descended into the quantum world, the more a disturbing pattern began to emerge. Matter was disappearing, not physically, conceptually. The universe no longer looked solid. Atoms were mostly empty space. Particles behaved like probabilities. Quantum fields replaced physical objects. Space and time themselves began showing signs of instability at extreme scales. And then a terrifying possibility entered modern physics. What if matter is not fundamental at all? What if reality is built from information? At first, the idea sounded absurd. Information belongs to computers, language, symbols, communication. It does not sound like the substance from which galaxies, stars, black holes, and human beings should emerge. Yet quantum mechanics kept pointing in the same direction. At the smallest scales of existence, physical systems behave less like objects and more like encoded probabilities waiting to resolve into measurable outcomes. The universe began resembling a computational process rather than a mechanical structure. And nowhere did this become more disturbing than inside black holes. For years, black holes represented one of the greatest paradoxes in science. According to classical physics, anything falling into a black hole disappears forever. Information destroyed, identity erased, matter lost beyond recovery inside gravitational collapse. But quantum physics refused to accept that conclusion. Because in quantum mechanics, information cannot truly vanish. That single contradiction triggered a crisis among the greatest physicists alive. If black holes destroy information, quantum theory breaks. If information survives, then black holes cannot function the way Einstein's universe predicts. One of the two pillars of modern physics had to be incomplete. Then came a revelation so shocking, it changed the direction of theoretical physics forever. Some scientists proposed that space itself may emerge from quantum information networks existing beneath visible reality. In other words, space-time might not be the foundation of the universe. Information might be. The implications were staggering. Everything humanity experiences could emerge from invisible quantum relationships encoded beneath physical existence. Matter, energy, gravity, even time itself might arise from deeper informational structures woven into reality like hidden architecture. The universe was no longer behaving like a collection of objects. It was behaving like a system processing possibilities. Suddenly, ancient philosophical questions returned with terrifying force. What is physical reality? What does it mean for something to exist? Is the universe fundamentally material or mathematical? Some physicists began exploring theories so radical they sounded almost forbidden. The holographic principle suggested our three-dimensional universe may emerge from lower-dimensional information encoded on cosmic boundaries. Quantum gravity researchers proposed that space-time itself could dissolve at fundamental scales into networks of pure relational data. Reality stopped looking physical. It started looking generated, not necessarily artificial, but emergent, constructed from something deeper than matter. And then scientists encountered an implication even more disturbing. If reality emerges from probabilities before observation, if physical states crystallize only through interaction, if information lies beneath space-time itself, then the solid world humans experience every day may not exist in the stable way we instinctively believe. Your body feels solid. The earth feels fixed beneath your feet. The stars appear distant and permanent. But quantum physics suggests this stability may emerge from deeper layers of uncertainty, constantly fluctuating beneath existence like invisible oceans of possibility. The universe is not static. It is continuously becoming, moment after moment, observation after observation, interaction after interaction. And for many scientists, this realization triggered a profound emotional crisis. Because humanity had spent centuries believing science would eventually remove mystery from the cosmos. Every discovery seemed to pull back another curtain, another equation, another mechanism, another certainty. Instead, modern physics uncovered something completely unexpected. The closer we moved toward ultimate reality, the less reality resembled anything the human brain evolved to understand. Particles became waves, waves became probabilities, space became unstable, time became uncertain, matter became information, and certainty itself began collapsing into abstraction. Some physicists embraced the mystery with awe. Others openly admitted the conclusions felt unbearable. Because beneath the mathematics lurked a question so dangerous that even now science struggles to answer it directly. If reality emerges through observation and information, what role does consciousness actually play in the universe? That question would soon push physics beyond science alone and into one of the most controversial intellectual battlegrounds in human history. The most dangerous question in science. At some point, the equations stopped being the frightening part. The mathematics worked. That was the problem. Again and again, quantum mechanics predicted outcomes with terrifying precision. The calculations matched reality so accurately that modern civilization itself was built upon them. Every smartphone, every satellite, every quantum experiment confirmed the same uncomfortable truth. Quantum physics was not failing. Human intuition was. And buried inside those equations was a question so unsettling that many scientists preferred not to discuss it publicly. What is reality when nobody is looking? Not philosophically, physically. The question sounds simple until you truly confront its implications. Imagine an electron existing in multiple possible states before measurement. Quantum mechanics describes these possibilities as a wave function, a cloud of probabilities containing every potential outcome simultaneously. Only when observation occurs does the system appear to collapse into one measurable reality. But what exactly counts as an observation? That single question fractured modern physics into competing interpretations, each more disturbing than the last. Some scientists argued observation has nothing to do with consciousness. According to this view, interaction itself causes quantum systems to settle into definite states. Particles collide. Systems exchange information. Reality stabilizes automatically through physical processes. Comforting, clean, mechanical. But not everyone was convinced, because quantum theory never fully explains why one possibility becomes real while countless others disappear. And in that unresolved gap, stranger ideas began emerging. A few physicists and philosophers proposed something radical. Consciousness itself may play a role in shaping measurable reality. not through magic, not through mysticism, but through the act of awareness interacting with quantum systems. The idea sounded dangerous from the beginning. Science had spent centuries separating itself from superstition, religion, and metaphysical speculation. The scientific revolution succeeded precisely because it focused on objective reality independent of human perception. Now, quantum mechanics appeared to blur that boundary again. Suddenly, consciousness was no longer merely observing the universe. It seemed entangled with the process by which reality becomes definite. Many physicists rejected this interpretation immediately. Some considered it intellectually irresponsible. Others feared it would invite pseudoscience into serious physics. Yet the discomfort never fully disappeared, because no interpretation completely solved the mystery. The Copenhagen interpretation claimed reality remains fundamentally uncertain until measurement occurs. The many worlds interpretation proposed that every quantum possibility actually happens, branching into endless parallel universes. Pilot wave theories attempted to restore hidden order beneath quantum chaos. Relational quantum mechanics suggested reality itself depends on interactions between observers. Each explanation solved one problem while creating another. And beneath them all remained the same terrifying possibility. The universe may not possess a single objective reality independent of observation. That idea struck at the foundation of human existence. For thousands of years, humanity assumed reality existed in fixed form outside the mind. Mountains stood whether humans existed or not. Galaxies burned across cosmic darkness long before consciousness emerged on Earth. But quantum mechanics introduced a fracture into that certainty. Not because it proved consciousness creates the universe, but because it revealed that observation and reality are more deeply connected than science ever expected. Then came experiments that pushed the mystery even further. Delayed choice experiments suggested particles appear to decide how they behaved after events had already occurred. Quantum eraser experiments implied information in the present could influence how reality manifests from the past. Cause and effect itself began unraveling. The universe no longer behaved like a timeline unfolding mechanically from past to future. It behaved like a web of probabilities interconnected beyond ordinary human logic. Some physicists quietly admitted the implications felt almost unbearable. Because if time, matter, observation, and information are fundamentally linked beneath reality's surface, then consciousness may not simply exist inside the universe. It may participate in the structure of existence itself. Not as the creator of reality, but as part of the process through which reality becomes experienced. And suddenly, science found itself approaching questions once reserved for philosophy alone. Why does consciousness exist at all? Why does the universe permit awareness? Why should a cosmos made of particles and forces produce beings capable of observing it? The deeper physics explored these mysteries, the stranger existence became. Because the universe did not merely appear mathematically ordered, it appeared strangely participatory, as though observer and observed were woven together inside the same cosmic process. That realization disturbed many scientists, but for one man in particular, it became almost impossible to accept. His name was Albert Einstein, and he was about to wage war against the universe he helped humanity discover. What if Einstein was wrong? Albert Einstein helped humanity reshape reality. Before him, space and time were considered separate things, fixed, absolute, independent. Then Einstein revealed something extraordinary. Time could slow down, gravity could bend space itself, and the universe was far stranger than Newton had ever imagined. It was one of the greatest intellectual revolutions in history. And yet, despite transforming modern physics forever, Einstein spent the final decades of his life fighting against the very future science was moving toward. Because quantum mechanics terrified him, not because he failed to understand it, but because he understood it too well. Einstein saw the equations, he saw the experiments, he recognized the terrifying power of quantum theory, but emotionally and philosophically, he could not accept what the theory implied about reality itself. A universe governed by probabilities instead of certainty, particles existing in undefined states before measurement, instantaneous connections across impossible distances, reality behaving differently when observed. To Einstein, something about it felt incomplete. The universe, in his view, had to possess deeper hidden order beneath the apparent chaos of quantum mechanics. Nature could not fundamentally depend on randomness. Physical reality had to exist objectively, whether anyone measured it or not. That belief drove one of the most important scientific conflicts ever witnessed: Einstein versus the quantum world. When he declared, "God does not play dice with the universe," he was not making a religious statement. He was expressing a profound conviction that reality must ultimately obey rational certainty. But quantum mechanics kept refusing to cooperate. Every new experiment strengthened the theory Einstein distrusted, and nowhere was this conflict more intense than in his debates with Danish physicist Niels Bohr, one of the architects of quantum theory. Their arguments became legendary, two of the greatest minds in history standing at opposite edges of reality itself. Einstein attacked quantum mechanics relentlessly. Bohr defended it relentlessly. Einstein designed thought experiments attempting to expose flaws in the theory. Bohr answered them one by one. The debates stretched across years, then decades, evolving into something larger than science. It became a philosophical war over the nature of existence. At stake was one terrifying question: does reality exist independently of observation? Einstein believed the answer had to be yes. Bohr believed the question itself might be meaningless. And then Einstein launched what he believed would become the fatal blow against quantum mechanics. In 1935, alongside physicists Boris Podolsky and Nathan Rosen, Einstein published what became known as the EPR paradox. The paper described entangled particles influencing each other instantly across distance. Einstein considered the conclusion absurd. If quantum mechanics predicted such behavior, then the theory had to be incomplete. Surely hidden variables existed beneath the equations. Surely reality preserved locality and determinism somewhere beneath the chaos. Einstein was certain future science would eventually restore order. Instead, the opposite happened. Decades later, experimental physicists began testing the paradox directly, and the universe sided against Einstein. Again and again, experiments confirmed entanglement. Again and again, Bell's inequality violations eliminated classical hidden variable explanations. Again and again, reality behaved exactly as quantum mechanics predicted. The implications devastated the old worldview. Einstein's vision of a deeply ordered, locally deterministic universe began collapsing under experimental evidence. One of history's greatest scientific minds appeared unable to emotionally accept the nature of the reality his own discoveries helped uncover. And perhaps that is what makes this story so profoundly human. Einstein was not weak. He was confronting something psychologically unbearable. Because quantum mechanics did not merely challenge scientific assumptions, it challenged the deepest instincts of human perception. The human brain evolved to survive in a world of solid objects, stable time, clear causes, and visible separation. Quantum reality destroys all of that. It reveals a universe operating according to principles so alien that even genius struggles to process them emotionally. And yet, the evidence kept growing stronger. Quantum computers began harnessing superposition. Entanglement became experimentally undeniable. Physicists started exploring theories where space-time itself emerges from quantum information. The universe no longer resembled the elegant certainty Einstein hoped to preserve. It resembled something stranger, a reality built from probabilities, relationships, uncertainty, and invisible connections beyond ordinary intuition. And this raised an even more unsettling possibility. Maybe humanity's discomfort with quantum mechanics is not proof the theory is wrong. Maybe it is proof that the universe was never designed to make intuitive sense to creatures like us. That realization marked the beginning of a profound existential collapse inside modern physics. Because once certainty disappears, everything changes. The collapse of certainty. Human beings crave certainty. We build our lives around it. We wake believing tomorrow will arrive. We trust the ground beneath our feet. We assume cause leads to effect, that time moves forward, that reality remains stable when we close our eyes at night. Certainty is not just comforting, it is the psychological foundation of civilization itself. But quantum physics quietly introduced a terrifying possibility. Certainty may never have truly existed, not at the deepest level of reality. The implications reach far beyond laboratories and equations. They reach directly into human identity, free will, consciousness, and existence itself. Because if reality is fundamentally probabilistic, then the universe is not unfolding like a scripted machine. It is unfolding through possibilities. That distinction changes everything. For centuries, classical physics encouraged a deterministic vision of existence. If an intelligence powerful enough could know the position and motion of every particle in the universe, it could theoretically predict the future perfectly. Every choice, every event, every thought. The cosmos would function like a giant chain reaction stretching across eternity. Quantum mechanics shattered that dream. At the subatomic level, outcomes are not fully predetermined. Physics can predict probabilities with extraordinary accuracy, but not definite outcomes before measurement. Nature itself appears fundamentally uncertain, and that uncertainty opened one of the most profound questions humanity has ever faced. Do we possess genuine freedom inside an indeterminate universe? Some scientists argue quantum uncertainty may create room for free will to exist beyond strict mechanical determinism. Others insist randomness alone does not create meaningful choice. The debate remains unresolved, but the emotional impact is undeniable, because suddenly humanity is no longer trapped inside a perfectly predictable machine. Reality contains openness, potential, uncertainty woven into existence itself, and then consciousness enters the equation. Why should a universe governed by blind particles and mathematical laws produce self-aware beings capable of reflecting on their own existence? Why should matter awaken into experience at all? This question became known as the hard problem of consciousness, and despite centuries of philosophy and neuroscience, nobody truly understands how subjective awareness emerges from physical processes. Quantum mechanics made the mystery even deeper. Some researchers propose that consciousness might not simply arise from reality, it might participate in reality. Again, this does not mean thoughts magically control the universe. Serious physicists remain cautious about such claims. But the relationship between observation, information, and physical outcomes continues to challenge ordinary assumptions about awareness and existence. The unsettling truth is that science still does not fully understand what consciousness actually is. And perhaps even more disturbing, the universe itself appears strangely compatible with conscious observation. Physical constants seem delicately balanced for complexity to emerge. Quantum systems evolve into stable structures capable of supporting life. The cosmos produced stars, planets, chemistry, biology, and eventually minds capable of questioning the cosmos itself, a universe becoming aware of its own existence. That realization haunted thinkers across generations. Not because it proves humanity is special, but because consciousness appears deeply woven into the story of the universe. Then comes the most difficult question of all. Is reality objective? Most people instinctively assume there is one fixed universe experienced identically by everyone. But quantum mechanics complicates this assumption in disturbing ways. Some interpretations suggest reality itself may depend on interactions between systems and observers. Others imply countless parallel outcomes unfolding simultaneously beyond human perception. The stable world humans experience could emerge from deeper quantum processes the brain naturally filters into coherent experience. If true, then what we call reality may be only one layer of something vastly more complex beneath the surface. And suddenly, the old certainties begin collapsing one by one. Space may not be fundamental. Time may not flow the way humans perceive it. Matter may emerge from information. Observation may shape outcomes. Consciousness may participate in existence more deeply than science currently understands. The universe no longer resembles a cold mechanical structure drifting meaninglessly through darkness. It resembles an unfolding mystery, beautiful, terrifying, infinite. And standing in the middle of that mystery is humanity, a temporary species orbiting an ordinary star, somehow capable of contemplating realities beyond its own evolutionary comprehension. Perhaps that is the strangest discovery of all. Not that the universe is mysterious, but that the universe produced minds capable of recognizing the mystery. And once that realization settles into the human imagination, fear slowly transforms into something else. Wonder. The new vision of the universe. For a long time, humanity believed mystery was temporary. Every unanswered question appeared destined to become another solved equation, another conquered frontier, another mechanism decoded by science. The future seemed clear. As knowledge expanded, mystery would disappear. But quantum physics revealed something astonishing. The deeper we understand the universe, the more profound the mystery becomes. And strangely, that realization may be one of the most beautiful discoveries in human history. Because quantum mechanics did not destroy reality, it expanded it. The universe is no longer confined to the cold mechanical picture humanity once imagined. It is stranger, richer, more interconnected, and more astonishing than classical physics ever allowed us to dream. Particles separated across vast cosmic distances remain mysteriously linked. Empty space vibrates with invisible quantum fields. Black holes may encode information like cosmic memories written onto the structure of space-time itself. Reality unfolds through probabilities instead of rigid certainty, and consciousness emerged inside this vast unfolding cosmos capable of questioning its own existence, not despite the universe, because of it. For centuries, science and wonder were often portrayed as opposites. Many feared that understanding the cosmos would somehow reduce its beauty, stripping existence of mystery and meaning. The opposite happened. Every major discovery made reality more extraordinary. Galaxies became larger than imagination, time became flexible, black holes became gateways into the limits of physics itself. Quantum mechanics revealed that beneath ordinary experience lies a hidden ocean of uncertainty and possibility, unlike anything the human mind naturally expects. And yet somehow, against impossible odds, consciousness arose inside this cosmic process. You are part of that story, a collection of atoms forged inside ancient stars, particles born from quantum events billions of years ago, now organized into awareness capable of contemplating the structure of existence itself. The universe became conscious enough to ask questions about its own nature. That idea carries a strange kind of poetry, not mystical certainty, not religious dogma, but profound scientific wonder. Because modern physics no longer presents humanity as detached observers standing outside the cosmos. We are participants inside a living process of discovery, emerging from the same laws we seek to understand. And perhaps that is why quantum mechanics feels so emotionally overwhelming. It does not merely challenge equations, it challenges the human need for simplicity. The universe is not obligated to conform to intuition. Reality is not required to resemble the narrow survival instincts shaped by evolution on a small planet orbiting an ordinary star. The cosmos is under no obligation to make sense emotionally, and yet, despite its strangeness, the universe remains astonishingly beautiful. The same quantum laws that create uncertainty also allow stars to shine. They allow atoms to form. They allow chemistry, biology, memory, emotion, music, thought, and life itself to exist. Without quantum mechanics, matter would collapse. The sun would not burn. The elements inside your body would never have formed. The mystery is not separate from existence. The mystery is what makes existence possible. That realization transforms fear into awe. Because uncertainty no longer feels like a failure of science, it becomes evidence that reality is deeper than humanity once imagined. The ancient dream of a perfectly predictable universe may be gone forever. In its place stands something far more extraordinary, a cosmos alive with possibility, interconnected beyond visible boundaries, endlessly unfolding across scales the human mind can barely comprehend. And perhaps the greatest lesson quantum physics offers is not that reality is broken. It is that reality is far more magnificent than certainty ever allowed us to see. For the first time in history, humanity stands at the edge of understanding with enough knowledge to recognize how much remains unknown. Not weakness, not defeat, wonder. The kind of wonder that drove ancient humans to stare into the night sky asking impossible questions beneath the stars. The same wonder that built telescopes, particle accelerators, quantum theories, and spacecraft capable of reaching beyond Earth itself. And now, after centuries of searching, science has arrived at a breathtaking conclusion. The universe is not becoming less mysterious. It is becoming more mysterious the closer we get to the truth. And somewhere inside that mystery may lie discoveries even stranger than anything humanity has imagined so far. The universe is still watching. Tonight, somewhere beyond Earth, particles are still dancing through the quantum world exactly as they did before humanity existed. Invisible fluctuations ripple through empty space. Entangled particles remain connected across impossible distances. Stars collapse into black holes. Galaxies drift silently through expanding darkness. And beneath it all, reality continues operating according to laws that humanity still barely understands. That may be the most humbling realization quantum physics has given us. The universe was never waiting for human certainty. For thousands of years, civilizations searched for stability. Philosophers, scientists, and theologians all attempted to construct systems capable of explaining existence completely. Humanity wanted clarity, final answers, permanent foundations, but reality kept escaping every attempt to confine it. Every time science believed it had reached the edge of understanding, the universe opened another abyss beneath our feet. Newton explained gravity, then Einstein bent space-time itself. Einstein organized the cosmos, then quantum mechanics shattered certainty again. Now physicists search for theories capable of uniting gravity, space-time, and quantum information into a deeper framework still hidden beyond human reach. And perhaps one day, even those theories will fracture beneath discoveries yet to come. Because the history of science is not the history of certainty, it is the history of humility. A gradual realization that reality is always larger than the models humans build to describe it. Quantum physics forced humanity to confront something emotionally difficult but profoundly beautiful. The universe is under no obligation to behave according to human intuition. Reality is not strange because science failed. Reality is strange because existence itself is stranger than the human brain evolved to comprehend. And yet somehow, despite our limitations, we continue reaching toward it. That is the miracle of consciousness. A species born on a small planet orbiting an ordinary star became capable of detecting invisible particles, measuring distortions in space-time, and questioning the deepest structure of existence itself. The atoms inside your brain were forged in stellar explosions billions of years ago. Quantum events unfolding across cosmic history eventually became thought, memory, imagination, curiosity. You are not separate from the universe observing itself. You are one of the ways the universe experiences its own existence. And perhaps that is why the mystery feels so personal. Because quantum physics did not merely reveal hidden mechanisms beneath matter. It revealed the limits of certainty itself. It revealed that observation changes reality, that space may emerge from deeper connections, that matter dissolves into probabilities, that time may not function the way human beings instinctively perceive it, that existence itself may be far more interconnected than civilization ever imagined. And standing at the center of all these revelations is one haunting truth. The universe is still unfinished in the human mind. There are questions science cannot yet answer. What is consciousness? Why does reality collapse into definite outcomes? What exists beneath space-time? Why does the universe permit awareness at all? Nobody knows. And perhaps that uncertainty is not a weakness to overcome. Perhaps it is the doorway to the next revolution in human understanding. Because every major discovery in history began the same way, with confusion, with paradox, with impossible observations that shattered the old vision of reality. Quantum physics may feel unsettling because it forces humanity into a completely new relationship with existence. Not masters of certainty, not detached observers standing outside creation, participants inside a living mystery, a mystery still unfolding, even now, at this very moment. Somewhere inside a laboratory, a physicist is staring at data that should not exist. Somewhere inside deep space, quantum events are unfolding in silence beyond human perception. And somewhere inside your own mind, the universe has become aware enough to ask the question that changes everything. What if reality was never what we believed it to be? Perhaps the greatest discovery was not that quantum physics broke reality. Perhaps the greatest discovery was that reality was always far more extraordinary than humanity dared to imagine.